Hello there, Mr. Sutton here, bringing you the IM325 classwork solutions on extra practice with factoring advanced trinomials. To factor this trinomial, we notice first that we have an a value that's not 1. It doesn't look like we can take out a common factor, which we always try first. So we either need guess and check or the AC method. I'm going to go with AC. So we got 7 times 16. That's going to be, let's see here, it's like 70 plus 42, that's 112, positive 112. So I need factors of 112 that add up to negative 22, and they'll both be negative because they multiply to a positive and add up to a negative. Okay, so what do we have here? We've got 1 and 112, definitely doesn't work. 2 and 56 also will not work. 3 doesn't go into this. There's 4 and 28. But that's not going to add up to 22. Close, but not quite. Let's see here. 6 won't go into it if 3 doesn't. 7, does 7 go into this? Well, 7 goes into 98, goes in there 14 times. So this would be 7 times 16. That's 23. That is so close, but it's still not what we need. Well, what else is there? Does 8 go into this? Well, let's see here. 8 goes into 96. 16 times, right? So, no, it doesn't go into 96. It's 12 times. So this would be 8 times 14. 8 and 14 adds up to 22. So it looks like 8 and 14, those are going to be our magic factors here. So I'm going to split this up into negative 8b minus 14b. And then I'm going to factor by grouping since I have 4 terms. Let me take a b out of the first group here, so that's going to be 7b minus 8. And then for the next pair, we can take out a negative 2, leaving me with 7b minus 8. I can take the 7b minus 8 out of everything as a common factor, and that leaves b minus 2 as my leftovers to go right next to it. On this one, since I don't have an a value of 1, and I can't just factor 11 out of all this stuff, I'm going to use the AC method. 11 times 6 gives us an AC value of 66. So now I need factors of 66 that add up to 35. So 1 and 66 won't do it. 2 and 33. Well, that adds up to 35, so I think that's what we're looking for. So I'll split up my 35 into 2x plus 33x. And now since I have 4 terms, I can factor by grouping. For the first 2 here, I can take out an x, leaving me with 11x plus 2. And then for the next 2 terms, I can take out a 3. That's also going to be 11x plus 2 if I do that. Now I can factor out the 11x plus 2, and I'll put the leftovers, x plus 3, in a parentheses next to it. For this problem, we notice there's an a value that's not 1. Let's start by trying to take out a common factor. We got 4 and 52 and 160. I think 4 goes into all of those. So if I take a 4 out, we have an x squared minus, this is going to be 13x plus 40. And since the inside stuff now has an a value of 1, this is really 1x squared inside the parentheses, I'm going to just find factors of 40 that add up to negative 13. So we've got, and they're going to both be positive because they multiply to a positive, so they have the same sign and they add up to a negative. So actually they'll both be negative. So we've got, let's see, 40 and 1, that adds up to 41. 2 and 20 doesn't work. 4 and 10, close, adds up to 14. What else is there? Oh, 5 and 8. Yeah, if we split this into negative 5 and negative 8, that would do the job. That adds up to negative 13. So then I'm going to break this up into 4, parentheses x minus 5, x minus 8. For this one, we have an a value that's not 1, and I can't just factor a 5 out of everything. So let me use the AC method to factor this trinomial. 5 times negative 27, that's going to be negative, let's see here, 135. So I need factors of 135 that add up to negative 42. And I know they have opposite signs because they multiply to give me a negative. So there's 1 and 135, not even close. Does 3 go into this? I believe it does, 3 and 45. So if I had a positive 3 and a negative 45, that would add up to negative 42. So let me split this up then into plus 3x minus 45x. And then I'll factor by grouping since I have 4 terms. I'll take an x out of the first 2, leaving me with 5x plus 3. And out of the last two, I'm going to take, let's see, a 9, negative 9. That'll also be 5x plus 3 if I take out negative 9 from those. Now I can factor out the 5x plus 3 as a common factor. And x minus 9 goes next to that in a parentheses. For this one, I have an a value that's not 1. However, I can take a common factor out of all of these. 3, 51, and 216 are all divisible by 3. I'm going to take out a negative 3, in fact. So if I do that, I'm left with n squared. This is going to be positive 17n. And then 216 divided by 3 is going to be 72, so plus 72 here. So now I just need factors of 72 that add up to 17. And they'll both be positive. So we need, let's see here, 1 and 72 doesn't work. 2 and 36 is a no-go. 3 and 24, not quite. 4 and 18, it's closer. That adds up to 22. 6 and 12 adds up to 18, so we're getting very close. What else is there? We got 6 and 12. 7 doesn't work. 8 and 9. Oh, yeah, 8 and 9. 8 plus 9 is 17. So we've got negative 3, n plus 8, and n plus 9. For this one, we have an a value that's not 1, and I can't factor a 9 out of all these terms. 36 would work, but 20 doesn't. So I'm going to use AC method for this. 9 times 20 gives me an AC value of 180. So I need factors of 180 that add up to negative 36. And I know they'll both be negative because we're multiplying to a positive and adding up to a negative. So let's see, 1 and 180 doesn't do it, 2 and 90 doesn't work, 3 and 60 is a no, 4 and 45 not working, 5 and 36, well 36 is what we want to add up to, so that doesn't work, 6 and 30, oh yeah, 6 plus 30 is 36. So I can split this up then, they have to both be negative. I can split this up into negative 6k minus 30k. So now that I have 4 terms, let me go ahead and factor this by grouping. For the first two, I can take out a 3 and a k, leaving me with 3k minus 2 inside. And for these next two terms, I can take out a negative 10. That leaves me with 3k minus 2 there as well. So taking out that common factor of 3k minus 2, that leaves me with a 3k minus 10 for the other parentheses. On this one, we have an a value, a coefficient of the square term that's not 1, and it doesn't look like I can factor out anything. So let me go ahead and use the AC method. We'll do 9 times 100 for 900 for my AC value. So I need factors of 900 that add up to 100. And there's a whole bunch of factors you could go through. We've got 1 and 900, 2 and 450, 3 and 300, 4 and some other number. But eventually, you're going to get to 90 and 10, right? And that definitely adds up to 100. So I'm going to split this up into 10a plus 90a. And now I can factor by grouping since I have 4 terms. So for the first two, I'll take out just an a, leaving me with 9a plus 10. For the next two, I'll take out a 10. That leaves me with a 9a plus 10 there as well. Now I'll factor out the 9a plus 10 as its own common factor. And that leaves the leftovers, a and plus 10, in a parentheses together right next to it. For this problem, this looks nasty. We have a negative a value, certainly not 1. Let me start by seeing if I can at least take out a common factor to make this easier before I go to the AC method. So we've got 7, 63, and 56. Those are all divisible by 7. So let me take out a negative 7 from all this. That'll leave me with an x squared plus 9x plus 8. And now for the inside, I just need factors of 8 that add up to 9. That would just be 8 and 1. So I can split this stuff in here up into x plus 1, x plus 8, and don't forget to bring down that negative 7. On this problem, we have an a value that's not 1, and we can't factor out any common factors here. So let's just go to the AC method. 6 times negative 35, let me do that on the calculator. So that's going to be, let's see here, 6 times 35 is 210, so negative 210 then. Now I need factors of negative 210 that add up to negative 1. 1 and 210 is not going to do the job. Neither will 2 and 135 or 3 and 70. Let's see, how many times does 4 go into that? Let me use the calculator to do the rest of these. So we have 210 divided by 4. That's not even going to work. 210 divided by 5 gives us 42. 210 divided by 6, that's 35. 210 divided by 7, well, I know that's 30, so that's not even close. If I do 30 minus 7, 210 divided by 8, nope. 210 divided by 9 is not going to work because the digits don't add up to 9. Divided by 10 is 21, so that's at least getting closer. Still not what we need. Does 11 go into that? Nope. How about 12? Nope. 13? It's worth a shot, right? Got the calculator out. Might as well try it. 14. Ah, there we go. Struck some gold there. So 14 times 15 would give us 210. So if I do positive 14 and negative 15, that's the way to go on this one. That would give me negative 1. So I've got 6v squared plus 14v minus 15v minus 35. And now I can factor by grouping because I have 4 terms rather. All right, so we've got 2v coming out of the first 2 terms. That's going to be 3v plus 7 left over. And I can take a negative 5 out of the last 2 terms. That's also going to be 3v plus 7 left over there. Factoring out that 3v plus 7, that's going to leave me with 2v minus 5. And then we're done. For this one, we have an a value that's not 1, and I can't factor out 10 to get my a value there to be 1. So let me try factoring with the AC method. So we have 10 times 18 gives me an AC value of 180. And I need factors now of 180 that add up to negative 27. So these factors will both have to be negative because it multiplies to a positive and adds up to a negative. So 1 and 180 won't do it. 2 and 90 doesn't work. We've got 3 and 60. That's not going to add up to 27. 4 and 45 doesn't work. What else is there? Let's see here. With 5 and 36, nope. 6 and 30, we're getting closer, but still no dice. And we've got 9 and 20. That adds up to 29. That's pretty close. 10 and 18 adds up to 28. That's even closer. How about 12? I know 12 goes in 15 times. 12 plus 15 adds up to 27. So that's going to work. So I'm going to split this up then into negative 12k minus 15k. And now I can use factoring by grouping since I have 4 terms. So for the first group, the first 2 here, I'm going to take out a 2k. Leaves me with 5k minus 6. For the next group, I'm going to take out, let's see, this will be a negative 3. Leaves me with 5k minus 6 there as well. So I can factor a 5k minus 6 out of both terms there. And that leaves me with my leftovers 2k and minus 3 in a parentheses next to it. For this one, we have an a value that's not 1. It's 2, and we can't factor 2 out of everything to fix that. So let me just go ahead and try the AC method on this. 2 times negative 24 is negative 48. So we need factors of negative 48 that add up to negative 13. And since they multiply to give me a negative, they have opposite signs. So we've got 1 and 48. That's not going to do it. 2 and 24 doesn't add up in any way to negative 13. How about 3 and 16? Well, that works if I do positive 3 and negative 16. So let me split this up into plus 3r minus 16r. And I can factor by grouping since I have 4 terms now. So let me take an r out of those first 2, leaving me with 2r plus 3. And for the last 2, I can take out a negative 8. Also leaves me with 2r plus 3. Now I'll factor the 2r plus 3 out of everything. And I can put the r minus 8, the leftovers, in a parentheses next to that. On this one, we notice that we have an a value that is not 1, so we look to see if we can take out a common factor, and it looks like we can. These are all divisible by 5, so if I factor a 5 out of that, I've got a p squared plus 11p plus 10, And now the inside here has an a value of 1. It's just 1p squared inside the parentheses. So I just need to find factors of 10 that add up to 11. Well, how about 1 and 10? That works out. So we've got a 5 that we're bringing down. We've got a p plus 1 and a p plus 10. And we are done.